Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over how to sketch quadratics using the vertex and opening. This standard is covered in Algebra 1, 2, and Pre-Calculus courses. Don't forget there are 6 practice problems at the end of this presentation that we'd like you to try out to demonstrate mastery of the content covered in this tutorial. If you'd like to gain access to our entire playlist and other valuable resources, take a look at the link in the description below, or just visit our website at mathgotserved.com. Alright, the instructions for the examples that we're going to be doing are as follows. We are to, for the given quadratics, for the given quadratic functions, the task is to find the axis of symmetry and the vertex, then sketch the graph. Okay, so it's not going to be a perfect curve. We're just going to sketch the graph of the quadratic, which is going to be a parabolic function. Okay, all right, so for number 1, let's say we have the quadratic function y equals x squared plus 10x plus 4. So we're going to start out by finding out the axis of symmetry. Okay, the axis of symmetry can be found using the x-coordinate. It's basically the x-coordinate of the vertex, and the x-coordinate of the vertex is negative b over 2a. Okay, all right, so let's do it. In this quadratic function that we have right here, this is a 1. A is 1, so that's a right there. B is 10, and C is 4. Okay, so if we want to find the x-coordinates of our vertex, we're going to compute negative b over 2a. So we're going to substitute 10 and 1 into this formula right here to find the x-coordinate of the vertex, which is the axis of symmetry. Okay, so let's figure that out. So it's going to be negative 10 divided by 2 times 1. We use the order of operations. We have negative 10 over 2, which is negative 5. Okay, so that's the x-coordinates of our vertex, and is also the axis of symmetry. Axis of symmetry is x equals negative 5. All right, the next thing we need to find is the vertex. Okay, so to find the vertex, we're going to use the formula x of v and y of v. Okay, so the vertex is going to be x-coordinate of the vertex, comma, y-coordinate of the vertex. Okay, and to find the y-coordinate of the vertex, you're basically going to be evaluating the function at the x-coordinate of the vertex. All right, so let's go ahead and do it. So to find the vertex, we need the x-coordinate of the vertex, and guess what? We already found it. The x-coordinate of the vertex is the same as the axis of symmetry. That's convenient. Negative 5. Now for the y-coordinate of the vertex, we're just going to do is plug in the x-coordinate of the vertex into the original function. Okay, so the original function is x squared plus 10x plus 4. And let's evaluate that at the x-coordinate of the vertex, which is negative 5. Okay, let's color code it so you can see what's going on here. So what we're going to do is we're going to take negative 5 and we're going to put it in the place of all the x's in the original function. Okay, so instead of x squared, it's going to be negative 5 squared plus 10 times negative 5 plus 4. Okay, Now we're just going to use order of operations. Please excuse my dear Aunt Sally to finish this off. Negative 5 squared is 25. 10 times negative 5 is negative 50 plus 4. Multiply and subtract left to right. 25 minus 50 is negative 25 plus 4. That is equal to negative 21. Okay? So based on this solution, our vertex, let's see, our vertex is going to be, you know what, let's put it down here. Our vertex is the x coordinate, negative 5, and the y coordinate, negative 21. Okay? All right, so let's go ahead and sketch what the graph is looking like. So we have the vertex. We notice that they're both negative, right? So it's going to be in the third quadrant. So somewhere here we have negative 5. Let's just call this negative 5 on the x, and then we can call this negative 21. So this point right here, negative 5, negative 21 is the vertex. Okay? So is our parabola going to be opening up or down? You look at the a value. Since a is positive, guess what? It's going to be a happy parabola. It's going to open up. Okay? So if a is positive, it opens up. If a is negative, guess what? It's a sad parabola, like negative people, right? Okay, so let's go ahead and sketch the graph. So the parabola that opens upwards is going to look something like this. Then like that. All right, it's just a sketch. And then our axis of symmetry basically means a line that splits the curve into two identical parts. All right, so there goes our axis of symmetry right there. So let's label the graph. So this is our vertex, negative 5, negative 21. And this line right here is the axis of symmetry. Axis of symmetry, and it's x equals negative 5. Alrighty, let's go ahead and take a look at the next one, question number 2. So question 2, let's say we have the quadratic y equals negative x squared plus 4x minus 9. Let's find the axis of symmetry first. The axis of symmetry is the x-coordinate of the vertex, negative b over 2a. Okay? So in this particular problem that we have, let's rewrite it again. Y equals negative 1 x squared plus 4x minus 9. A is negative 1, b is 4, and c is negative 9. So the axis of symmetry, which is the x-coordinate of the vertex, is negative b over 2a. So let's calculate that. It's going to be negative b, which is 4, divided by 2a, 2 times negative 1. If we apply the order of operations here, we'll have negative 4 over negative 2. And then you simplify that. Minus, minus, slash and dash, 4 over 2 is 2. Okay, so our axis of symmetry is x equals 2. Now let's find the vertex. So the vertex is basically the x-coordinate of the vertex and the y-coordinate of the vertex, where the y-coordinate of the vertex is what you get when you plug in your x-coordinate of the vertex into the original function. All right, so let's do it. So we already have the x-coordinate of the vertex, which is 2. To get the y-coordinate of the vertex, we're going to evaluate the function at the x-coordinate of the vertex, or basically y of 2. So let's rewrite our y so we know what's going where. Negative x squared plus 4x minus 9. Now we're going to plug in the x-coordinate of the vertex, which is 2, into all the x's. Okay, so you have that. So I took out all the x's and I replaced it with 2. That's basically what happens when you're evaluating a function at a particular x value. Applying the order of operations here, we have negative 4 plus 8 minus 9. Negative 4 plus 8 is 4 minus 9, and that gives us negative 5. So our vertex is the x-coordinate of the vertex and the y-coordinate of the vertex. All right, let's go ahead and graph the function. It's just a sketch. Now, the vertex has a positive x and a negative y, so we're going to be in quadrant number 4. Okay, so we're just going to go 2 units to the right and 5 units down. So negative 5 and 2. Okay, so put a point right here. And then, is it going to be a happy or sad parabola in this particular case? In this particular case, we need to look at A, okay? A tells us the mood of the parabola. So in this case right here, A is negative 1, okay? So since A is negative, the parabola is going to be a sad parabola, right? Okay, sad parabola since A is negative. Now let's go ahead and graph that. So all we do is we graph our parabolic function. Okay, it's going to be, the u is going to be opening downwards. Starting from the vertex is going to be the highest point, so it's going to be a u that's opening downwards like this. That's what a parabola is. So what's on the left and on the right should be exactly the same. I'm just trying my best here. It's just a rough sketch, so it doesn't really matter. Okay, and then let's draw our axis of symmetry. Our axis of symmetry divides it into 2 equal halves. Okay, so this is the vertex right here. Vertex. Vertex is 2, negative 5. And this line is your axis of symmetry. So here is the axis of symmetry. Axis of symmetry is the line x equals, what is it, 2. Bam. Alrighty, let's take a look at another example. So for number 3, let's say we have the quadratic function y equals 2x squared minus 8x plus 12. Okay, so we want to start by finding the axis of symmetry. Remember, the axis of symmetry is the x-coordinate of the vertex. You find the x-coordinate of the vertex by using the formula negative b over 2a. Okay, so let's go ahead and rewrite our quadratic function, specifying what a, b, and c are. 2x squared minus 8x plus 12. So a is 2, b is negative 8, and c is 12. Okay, now let's calculate it. The x-coordinate of the vertex is negative b over 2a. So we're calculating negative 8 over 2 times 2. Okay, using the order of operations, if we simplify this, it's going to be 8 over 4. So 8 over 4 is 2. So our axis of symmetry, which is the same thing as the x-coordinate of the vertex, is x equals 2. All right, now that we have that, let's go ahead and find the vertex. So the vertex can be found using the formula x vertex comma y vertex. And the y vertex is the function evaluated at the x vertex. Alrighty, now we already know what the x vertex is because we just looked for it here. So the x coordinate of our vertex is 2. Okay. And then to find the y coordinate of our vertex, we're just going to take the x coordinate of the vertex, which is 2, and plug it into the function. Okay, so our function that we're talking about is the original one, 2x squared minus 8x plus 12. So what we're going to do is plug in 2, which is the x coordinate of our vertex, into it. Okay, so we have So that's the function. I took out all the x's, so I'm going to replace it with the x coordinate of the vertex, which is 2. All right, so now we're going to use the order of operations. Please excuse my dear Aunt Sally to do this. So we'll do the powers first. So it's 2 times 4. And then we can multiply these together. Minus 16 plus 12. All right, multiply. Before we add and subtract, 8 minus 16 plus 12. And then 8 minus 16 is negative 8 plus 12, which is 4. All right, let's go ahead and graph it. I want to graph this. Now, before we start graphing, let's specify what the vertex is. So a vertex is the ordered pair 2, 4. So in order to graph the parabola, the graph of the quadratic function, we need to know if it opens up or down. Okay, a is what? A is 2. So since a is positive, guess what? Is a happy situation. The parabola opens up. Okay, now our vertex is 2, 4, which is in quadrant number 1, because we're going to go to the right 2 units and up 4. So 2, 4. Let's sketch that. Remember, this is not a precise graph, it's just a rough sketch. Okay, so 2, 4. So we have 2, 4. And 1, 2, 3, 4. Okay, so that's where our vertex is going to be, okay? Now, in this particular situation, it's a happy parabola, so it's going to be opening upwards. Okay, so it opens up. Opening up. And then our axis of symmetry is going to be right here. Okay, so let's go ahead and label our graph. What do we have? So our vertex, this is the vertex right here. Vertex is a point, 2, 4. And then this vertical line, this line of symmetry is our axis of symmetry, okay? So this line is our axis of symmetry. And it is given by the equation x equals what? X equals 2, the x coordinate of our vertex. Alrighty, we're gonna do one more practice problem, and then I will give you an opportunity to try some on your own. See how well you do with those. So for the last one, let's say we have the quadratic y equals 5x squared plus 10x minus 3. I want to start by finding the axis of symmetry. Okay, so following the same procedure as we did for numbers 1, 2, and 3. So the axis of symmetry is the x coordinate of the vertex, which is negative b over 2a. So let's rewrite the function y equals 5x squared plus 10x minus 3. So with this format, we know what a, b, and c are. A is 5, b is 10, and c is negative 3. So to find the x coordinate of our vertex, we're calculating negative b over 2a. So that's going to be negative 10 over 2 times 5. Using the order of operations, we have negative 10 over 10, which is equal to negative 1. Okay? So our axis of symmetry, which is the same thing as the x coordinate of the vertex, is x equals negative 1. Perfect. Moving along, now let's go ahead and find the vertex. The vertex of our quadratic function is the x coordinate of the vertex and the y coordinate of the vertex. The y-coordinate of the vertex is a function evaluated at the x-coordinate of the vertex, okay? So we already know what the x-coordinate of the vertex is. What is it? Well, it's -1. We don't have to do any more work. To find the y-coordinate of the vertex, we're looking at a function evaluated at the x-coordinate of the vertex, which is -1. All right, so let's go ahead and rewrite the function. Y equals 5x squared plus 10x minus 3. And then we're going to plug in -1 for the x's in order to evaluate the function at the x-coordinate of the vertex. Okay. Now that we have it plugged in, we're going to use the order of operations to simplify this. So we have, what do we have? -1 squared becomes positive. 5 minus 10 minus 3. So y of the vertex is going to be, let's see, 5 minus 10 is -5 minus 3. Y-coordinate of the vertex is -8. So our vertex for this quadratic function is -1, -8. Bringing together the x-coordinate of the vertex and the y-coordinate of the vertex. All right, so the last part is to graph. In order to graph it, we need to know the orientation of the parabola. Does it open up or down? In this particular case, A is positive 5. Okay, so since A is positive, that means that we have a happy parabola right here. It opens up. So all we just need to do is find where the vertex is, and then we'll draw an upward opening parabolic curve. -1, -8 is in quadrant number 3. So let's sketch that. So -1, and then -8, 2, 4, 6, 8. Let's just go by 2's. So our vertex, -1, -8 is somewhere here. So we just draw in our quadratic function. Our parabola looks something like this. Oh man, let's draw it again. Skinny little parabola right there. Okay, it's supposed to be like a U over here, okay? All right, so there goes our parabolic function. And then we'll split it down the center with the axis of symmetry. All right, so we'll split it. Let's split it down the center. So if we split it down the center, that will be our axis of symmetry, okay? So let's go ahead and label the graph. So this point right here, -1, -8, that point is known as your vertex. For a upward opening parabola, it's like a minimum point, okay? And then this line right here that splits the graph into 2, this line is called the axis of symmetry. Okay, it's symmetric because you have the same thing on both sides of the axis. And the axis of symmetry in this particular problem is x equals -1. Alrighty, now it's your turn to do some practice problems. So the instructions for these practice problems are exactly the same as the following. You're to find the axis of symmetry, the vertex, and sketch. All right, so it's just a sketch using the vertex and the axis of symmetry, and of course the opening. Alrighty, so these are 6 practice problems we'd like you to try out. So with these 6 quadratic functions, you're to find the axis of symmetry, vertex, and then sketch. Okay, so go ahead and pause this video presentation at this time. Work on these problems. When you're done, click back on the play button, and then we're going to reveal what the answers are. Alrighty, welcome back. So hopefully you had the chance to try out the problems. So let's go ahead and write down what the answers are. So for problem number 1, the axis of symmetry is x equals -3, and the vertex is -3, 1. And if you sketch the graph, it's going to be opening upwards. Okay, so let's say that's the axis of symmetry right there. The graph is going to be opening upwards. So your vertex is -3 and 1, and it opens up. Okay, because it's a happy parabola. Okay, number 2. The axis of symmetry for number 2 is x equals 4. And the vertex is 4, 4. Okay, and then let's go ahead and see what the graph looks like for number 2. It's going to be a downward opening parabola because a is negative, so it's going to open downwards like this, and your vertex is going to be 4, 4. Okay. Alrighty, let's take a look at number 3. For number 3, the axis of symmetry. The axis of symmetry is x equals 2, and the vertex is 2, 1. And then again. Okay, and then in this particular case, it's a happy parabola. A is positive. Okay, so if you have the vertex, you're gonna have a value that is positive. So you just have your vertex down here. See, that's 2, 1, and then it opens up. Okay, so there goes your graph. That's just a sketch. Number 4. So for number 4, your axis of symmetry is x equals -1, and your vertex is -1, 1. Okay, so let's see what the graph looks like. So if you sketch the graph, in this particular case for number 4, the graph opens upwards. Is a happy situation. Why is it happy? Well, because a is positive. Okay, so let's say this is the vertex right here on the axis of symmetry. -1, 1. It's going to be a happy situation. Parabola opening up since a is negative. For number 5, the axis of symmetry is x equals -3, and the vertex is -3, 3. And then the graph, this is a sad parabola right here since a is negative. Okay, so let's say this point is the vertex, which is -3, 3. It's going to be opening down like that. Number 6. So number 6, let's say your axis of symmetry. For this one, the axis of symmetry is x equals 4, and your vertex is 3. No, the vertex is 4, 3. In this particular case, is a happy situation, okay? The parabola opens upwards, so the vertex, let's put it down here, 4, 3, and it opens up like that. And this is your vertex, which is 4, 3. Okay? And let's not forget to specify the axis of symmetry. So for this one, the axis of symmetry is x equals -3. For this one, it's x equals 4. For number 3, the axis of symmetry is x equals 2. For this one, it's x equals -3. No, not -3. It's -1. So let's, for number 4, let's graph the vertex because I didn't do it. -1, 1. Okay? And then for number 5, The axis of symmetry is x equals -3. And then for number 6, x equals 4. Alrighty, so there goes the answers. Now, how well did you do on these 6 practice problems? Let us know in the comment section below how well you did. Now, if you have any questions or clarifications that you'd like us to make on any of these examples, just specify it in the comment section below and we'll be more than glad to assist you. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your studies of quadratics, do give us a like. Your positive feedback is very valuable to us. If you have any questions or comments as indicated earlier, just put it in the comment section below. And do not forget to subscribe to our channel for updates to tutorials. We do upload videos to our page on a weekly basis. More support resources can be found at our website, mathgotserved.com, or in the link in the description below. Thanks again for watching and have a wonderful day. Goodbye.